Alright, so number 9 on the practice exam. What is the major product of the following reaction sequence? So they give us this molecule here. So first they're gonna treat it with bromine, dibromine, and carbon tetrachloride. Then after that they're gonna treat it with the sodium, I think it's amide, sodium amide, to get the ammonia anion, and that's an excess, and that's all it's dissolved in NH3, and then they're going to treat it with acid, H3O+. So the first reaction that we're doing up here is addition, right? Addition of bromide to alkene. So it's 2 steps. So we have step 1. So in step 1, the pi bond acts like a nucleophile, gives its electrons to the bromine. This bromine breaks its bond, gives its electrons to the second bromine, which breaks off and becomes an anion. And we're left with this intermediate where we have a bridge where the pi bond was going to the bromine plus the bromine anion. This bridge, this is anti-addition. So this is, there's a bridge that forms, and it's an anti-addition. This is why it's anti-addition. This is how it's anti-addition. So step 2, the anti-addition. Now the bromine anion can come from any direction. It could go like this, in which this case, if it came like this, the bromine would come over here. And in the other case, if it was like this, so that's root B. So if it went through root A, this would attach here, and this bromine would come over here like this. Now this is not the case in this molecule, but if there were stereogenic carbons here, it would create enantiomers because it has 2 pathways it can go by. So it would create enantiomers. The anti-addition of bromine would create enantiomers, but these molecules don't have stereogenic centers, so we don't need to worry about that right now. So then, okay, that leaves us with, so we took the A path. Let's just pretend we take the A path. This bromine comes up here. This bromine comes down here. So we're left with the 2 bromines attach. The pi bond is broken. We have H, H, H. So this is our new molecule. So now we go on to, it's an acid-base reaction, right? I'm pretty sure. And then they use an acid-base reaction to create an alkyne. So what they do is they have this molecule and they treat it with sodium amide, right? That's the name of this molecule. Sodium amide dissolved in ammonia, and it's in excess. That's important. So the ammonia anion, the amide, the ammonia anion acts as a nucleophile, gives its electrons to this hydrogen, plucks it off. This bond gives both of its electrons here, creating a double bond, and then this bond breaks, giving both of its electrons to this bromine, and this bromine breaks off, and we are left with the following. Right? So then step 4, we continue from there. We're going to do that one more time to create our alkyne. So we have the sodium amide dissolved in ammonia. And it's in excess, and we'll see why that's important in a second. So now what it does, this sodium amide donates its electron pair to this hydrogen, plucks it off, this bond breaks, gives both its electrons to the double bond, creating a triple bond, and then this bond breaks, giving both of its electrons to the bromine to make a bromine anion. It breaks off, right? And that all creates this molecule. Now, this is where, so what happens is, because you have this sodium amide in excess, the sodium amide is now strong enough to pull off a terminal alkyne hydrogen. So that's what happens in step 5. What happens is the excess sodium amide, I'm sorry if I'm pronouncing that wrong, dissolved in ammonia, it can pluck off this hydrogen right here. It's strong enough, sending the electrons from this bond to the carbon, creating a carbanion at the end of this alkyne, right? So we get this carbanion, and that's why we treat it with acid, to replace that carbon, that hydrogen. So here we have the carbanion, right? And we treat it with acid. The carbanion donates its proton to one of the hydrogens, which breaks its bond with the oxygen, giving its electrons there. And then we get the normal alkane with the terminal hydrogen put back on because of the acid reaction. I'm sorry if this is like, if you can't see exactly what's going on, but I'm going to be posting these up in the Facebook group, so you'll be able to get them. Plus H2O, and that was number B, right? B. Yes.